Hey everyone! So we are going to be looking at solving trigonometric equations today. And you are going to need your unit circle for this. So I would recommend pausing this and going and finding your unit circle. Or if you know you left your unit circle at school or it's in the garbage or what have you not, there's thousands of them that you can print off of Google. That's actually where I get this one as well. So a couple refreshers before we begin, since it's been a while since we've seen the unit circle. Remember, the y piece is our sine. So the y piece of the point is the sine. Remember, the x is the cosine. And remember, we can find tangent by doing sine over cosine. That's one of our identities, our y over x. And you can see in my unit circle here in the orange, I've actually went around and found all of the tangents just to save me some time because I was feeling lazy. All right. So, like I said, today we are going to be solving trigonometric equations. And you're going to notice that a lot of the strategies that you've learned in solving other equations, like linear equations and quadratics, a lot of those strategies are going to come into play here. All right. So before we look at the trigonometric equation, I just want to bring you to, again, something similar, or something super simple that we've learned before, a linear equation. And when we would have solved this in Algebra 1, we would always get our x's on one side and everything else on the other, probably do some division, and we're done, right? We can do that same sort of thing when we have stuff like this. Sorry, I started this example and then I got interrupted, so I had to restart the video, which is why there's writing on it. Anywho, our directions are to find all of the solutions on the interval 0 to 2 pi. So the equation we're looking at is 2 tan minus the square root of 3 equals tan. So, like I said, we're going to use that same strategy as we would have up here. So the first thing we would want to do is get all of our x's, or in this case, all of our tangent of x's, on the same side. So it doesn't matter which tan we move. I'm going to move this one right here. So in order to move that over, I'm going to subtract 2 tans from both sides. So you can see those would cancel out. And then we would be left with the negative square roots of 3. And then 1 tangent minus 2 tans gives us a negative 1 tan. Our next step, that's where that division comes into play. I want to get my tan totally by itself. So right now it's being multiplied by negative 1. So in order to get rid of that multiplication by negative 1, I would divide both sides by negative 1. And now we're left with tangent of x equals positive square roots of 3. So now we are solving for an angle. So we want to know what angle makes this equation true. So remember, whenever we are solving for an angle, we're technically doing the inverse tan. So what we need to do is we need to look at our unit circle, and we need to figure out all of the places where tangent is the square root of 3 on our unit circle. Okay, so we need to figure out all the places where tangent is positive square root of 3. So you can see right here, pi over 3, that would be one answer because my tangent was square root of 3. I know there's one other place as well. And another place tangent is this positive square root of 3 is 4 pi over 3. And then those would be my two solutions. So that those are the only two angles I can plug in for x that would give me a true statement. All right, let's go ahead and look at another example. Kind of looks like this got cut off when it printed for whatever reason. So we have 2 minus 10 times the secant of x equals 4 minus 9 secant of x. And again, we're going to employ that same strategy. We want to get our secants on one side and everything else on the other. So let's see. I think in this case, I'm going to add 10 secants to both sides. And I think I'm going to subtract 4 from both sides as well. So when we do this, we're going to end up getting negative 2 equals 1, because negative 9 secant plus 10 secant gives me positive 1 secant. And look at that. We already have secant totally by itself, so we don't have to worry about division at all. So now again, this is saying we're technically finding an angle. So this is saying where on the unit circle is secant negative 2. And now we didn't have secants plainly listed on our unit circle. So let's use a shortcut. Let's make it easy on ourselves. Remember, secant is really the reciprocal of cosine. So we could look for where secant is negative 2, or we could look at the reciprocal, and we could look where cosine is negative 1/2. Those would be the same things. So look for the reciprocal function. So cosine, remember cosine is our x values. So I need to find all of the angles where x is negative 1/2. And it looks like we are at right here. So 2 pi over 3 would be a solution. And where else is x negative 1/2? It looks like the only other spot is at 4 pi over 3. And we are done. So again, those are the only 2 angles that I could plug in for x that would give me a true statement. All right, so that's kind of like a linear-ish aspect to solve those. Another way we can solve, think of you had something like this. I don't like that. Let's go 16. Okay. So if you had something like this, so 4x squared equals 16, what you would do is divide both sides by 4. And then in order to get rid of this square, you'd take the square root of both sides. And remember, whenever you add a square root, you also have to add that plus or minus as well. So the square root property is another strategy we learned to solve. And we can use the square root property here as well. So this time our equation is 4 sine squared plus 1 equals 4. So kind of like over here, remember we always want to isolate what's being squared first. So in this case, I'm going to go ahead and subtract 1 from both sides first. And then again, I need to isolate what's being squared. So I'm going to divide both sides by 4 to get sine squared equals 3/4. And now we have what's being squared totally by itself. So now I can take the square root of both sides. And remember, when I physically add in that square root, I also need to add that plus or minus in as well. So now the square root of sine squared is just plain old sine. Remember, when you take a square root of a fraction, you really take the square root of the top and take the square root of the bottom, and the square root of 4 is 2. And again, remember, whenever you're finding an angle, you're really looking at that inverse function. So we need to figure out on our unit circle all of the places where sine, and remember sine is our y value, where all of the y values are square root of 3 over 2, or in this case, it could also be negative square root of 3 over 2. So we're actually going to have 4 solutions for this one. All right, so if we look at our y values, there's one at pi over 3. There is another one at 2 pi over 3. Number 3 will be at 4 pi over 3. And our last one, we have another y value of negative square root of 3 over 2 at 5 pi over 3. This one actually has 4 different solutions that would work. All right, let's look at one more of using the square root property. So this time we have 3 cotangent squared plus 4 equals 7. And again, before we can use that square root property, we need to isolate what is being squared. So first thing I'm going to do is subtract 4 from both sides. And then I'm going to divide both sides by 3. And now what's being squared is totally by itself. So now I can add that square root. And remember, I also need to add the plus or minus as well. So we're looking for all of the places where cotangent is positive or negative 1. And I'm going to write it as 1 over 1 for right now. So again, I could go through and try and calculate all those cotangents, or I can look for that reciprocal function as well. So I know tangent is the reciprocal of cotangent. And if I take the reciprocal of 1 over 1, I'm just going to end up with 1 again. So another way to look for cotangent of 1 is to look at the tangent of 1. So on my unit circle, I need to look at all my orange and figure out all the places where tangent is positive or negative 1. So looks like we have one at pi over 4. At 3 pi over 4, we have a tan of negative 1. Five pi over 4, and the last one is 7 pi over 4. So again, we have 4 answers. All right, so there are the 2 strategies on solving trigonometric equations today. So we have our basic kind of linear type where we get all of the x's on one side and everything else on the other. And then you can see where we use the square root property as well. Have a good one, guys.